Hey, welcome to Chemistry Today. Starting off with this, we are moving on today. It's a new unit, and our first focus of this unit is electron configuration, as it says right here. Electron configuration, let's bold that. That's the title of your notes today. Make sure you're following along and taking notes as we do this, because this does involve, or this will be your notes for the day, and we will do this a lot from now on. So please make sure that you are following along with notes. Electron configuration can be the title of your notes. This refers to how electrons are located or where they're located throughout the atom. Now, a couple things we need to remember about the atom and about electrons. First, the number of electrons is dependent upon the atomic number. So hydrogen has 1 electron, silicon has 14 electrons, sulfur has 16 electrons. That is one thing you need to remember. Side note, this is the accelerated video. If it goes too quick for you, please go back to the 30-minute video that goes a little slower. So number of electrons is atomic number. Second thing that we have already gone over is the number of energy levels an atom has is based on its period number. Now, period number in our periodic table, period equals the row. So right here that I circled, that is row 1, also known as period 1. Period 2, period 3, period 4, etc. So period 1 only has 2 elements in it, hydrogen and helium. Period 2 has lithium all the way through neon. Period 3 has sodium all the way through argon, and so on and so forth. The period number determines how many energy levels we have. Now, Bohr's model, flashback. Bohr, he's got his nucleus and he's got his energy levels. We drew Bohr models. You all knew how to calculate the correct number of energy levels. The only thing Bohr was wrong about is the fact that he thought that all atoms were 2D, like not 3D. And so he thought each energy level looked just like this. He was wrong about that. Energy levels, these different energy levels, energy level 1, energy level 2, all have different shapes and have what are called subshells. Now, with our subshells, their different shapes are right here. You don't have to memorize the shapes, but the name or the letters associated with each subshell are important. I have them circled right here. I'll erase those circles so you can read it a little bit clearer. Don't worry about the number for now, just the letter. So we have 4 subshells. Our subshells are S, P, D, and F. So each one of these energy levels, this is energy level 1, this is energy level 2. These energy levels will have different subshells, and the subshells will be based upon where they're located in the periodic table. So S, P, D, and F, different energy level subshells, and they are shaped different. Sphere, and then you can see these different 3D shapes right here as we get to P, D, and F. So you're just writing the letter S, P, D, F. They are our subshells. Now, how we determine which subshell is which? Our rows here. That tells us what energy level it's on. Now, row 1, if you remember, with Bohr, and Bohr was correct with this, energy level 1 can only hold 2 electrons. You filled it in just like this. 1, 2. It can only hold 2 electrons. So, energy level 1 has no subshells. It's just right there. It can only hold 2 electrons, so it is just going to be S. Just S. Now, for the purposes of this, you can picture helium as being right here, because helium fits in with hydrogen really well and doesn't fit in on the other side of the periodic table really well. Helium. So just picture it over there for the rest of today. Now, on your way in, now that we've named our subshells, you know that our rows or periods tell us how many energy levels we'll have. You need to look at this paper you picked up on your way in. Now this is going to help us figure out how to do our electron configurations, and we're going to always start over here with 1s, and we are going to work our way all the way down. Today we're just focusing on these first 3, 1s, 2s, 3s, and 2p. Now with each energy sublevel, which again our subshells are S, P, D, and F, here, these 2 columns right here, just these 2 columns, these are always found in the S subshell. So you want to label that on your blank periodic table. These are found in the S subshell. These over here, all of these with the exclusion of helium, which we moved helium over here for the day, these are found in the P subshell. So over here is the P subshell, over here is the S subshell. Each subshell, S, P, D, and F, can hold a different number of electrons. S subshell can hold 2 electrons. So like this, our first S subshell, 1s, can hold 2 electrons. Our P subshell can hold 6 electrons. And that's all we're focusing on today. I will tell you though, our D can hold 10 electrons. Sorry, 10 electrons, and we'll get there eventually. We're not really going to get into F too much. So, but for today, the main focus, S can hold 2 electrons, P can hold 6 electrons. Now, you may be wondering, I thought every energy level could hold 8 electrons. Well, they can. But remember, we have, these are called subshells. So if we look, for example, at carbon, carbon is in our P section. So it can hold up to 6 on its P level. Its S level, level 2, can hold up to 2. So it would be 1, 2, 3, 4, 5, 6, 7, 8. So level 2 can hold 8 electrons. They're just separated into an S level, which looks like a sphere. It can hold 2 electrons. And then a P level, which can hold 6 electrons, meaning in total, level 2 can hold up to 8. So there's nothing changing. It's just separating those 8 into an S level and a P level. 2 will be found on the S level. 6 will be found on the P level. Now, with this, we have talked about it before. Each level, each energy level must be full before you move to the next one. You remember with Bohr's model, we always had to fill up this first energy level with 2 electrons before we could move to the second energy level. It's no different when writing electron configurations. You always have to fill up this 1s level, which stands for row 1 and the S section. You always have to fill that up first with 2 electrons before you move down here to the 2s level. As you can see, 2s. Then you have to fill up the 2s level with 2 electrons before you move on to the 2p. Sorry, refresh that. Before you move on to the 2p energy level. Then you have to fill up 2p before you can move on to 3s, just like that. Then you have to fill up 3s before you can move on to 3p right here. And remember, S, 2, and then 6, and then each energy level total will hold 8. So, how do you fill up these energy levels? How do you actually write electronic configurations? I just went through, you had to fill up each one. We're going to start off with how you write them with hydrogen. Hydrogen's always a good one to start off with. Now, let's get our pen ready. If we were doing hydrogen, hydrogen's located in the S section and it's located in period 1. So we'd write period 1, just like that. So that's located in our S section, so we would put S. And then it only has 1 electron. So to signify that 1 electron, we just write it right there, just like that, as a little superscript. So hydrogen is going to be 1s1. We get the 1 from its period. We get the S because it's in our S subshell right here, one of these 2 columns. And then we get the 1 because it has 1 electron. Good? Okay, let's look at helium. Remember, we moved helium over here for the day. So helium, you're going to picture helium as right here. So helium, we're going to erase hydrogen. We'll erase this. Okay, helium. Helium is located in our S section. It's located in row 1 again. So we're going to put period 1. It's located in our S subsection. So S, it has 2 electrons though. So we are going to write A2 just like that. You see here, 1s, we have now filled up because S, look right here, can only hold 2 electrons. So we have totally filled up energy level 1 with 1s2, row 1, subsection S, and 2 electrons. We filled up level 1. That means from now on, we can move on to level 2. You got to fill up this one before you can move to this one. Got to fill up this one before you can move to this one, etc., etc. So let's move on. Let's try one that would be in 2s. Let's look at lithium, our element number 3. Lithium. Okay. Lithium is located in period 2. So it's going to be over here in 2. And it's in the S subsection. So it's going to be 2s. But we have to make sure we know that we have filled up our first energy level before we move on to our second energy level. Just like when you drew a Bohr model, if you were drawing a Bohr model for lithium, you'd have your nucleus here, and then this would be your first energy level, you would still have to signify that you filled up the first energy level with 2 electrons, right? Then you moved on to the second energy level, and you showed that you only had 1 on the second energy level. But you still had to draw the first one and put 2 electrons right there, even though lithium's final electron was located on the last energy level. The reason I say that is if we're doing lithium, we still have to write that we filled up this first energy level, which was right here. We still have to write that we filled this up before we moved here, meaning lithium has 3 electrons. It's in row 2, right here, but that means we already filled up the 1s level. So we already passed this. We already filled up this 1s level right here. Already filled up the 1s level. So we need to signify that by writing 1s2. 1s2 is full. Its first energy level is full. We know that. Then we find out where lithium is. Lithium is in row 2, period 2, and it has 3 electrons, but we already signified that it used 2 of them on its first energy level, so we will put 2s, and how many electrons does it have in its outermost shell on its Bohr model? 1, so it's going to be 2s, 1, just like that. A lot of people like to work backwards. I think working backwards is easier sometimes too. If you wanted to work backwards with lithium, you would look and see, okay, we have lithium, it's right here. We know it's in our second period, so you wrote 2, it's in our second period, and its element, it's in our first column of our S subsection. So it's S subsection, period 2, S subsection, and then your number that's right here for your last little symbol is going to be the equivalent of the number of valence electrons. Remember, valence electrons you get from the columns. So this has 1 valence electron, this has 2, 3, 4, 5, 6, 7, 8, just like that. It'll be somewhat similar to that, not completely because we move on to new level. But anyway, if you work backwards, we see we have lithium. It's in our S section, row 2, column 1 of our S section, so we know it's going to have 2s1. Then you work backwards, you know the 1s subshell was already full, so 1s, and you know it could be filled with up to 2, that was a bad 2, but up to 2 electrons. So you know it's going to be 1s2, 2s1. And you can check your work by seeing lithium should have a total of 3 electrons, and you count them right here, 1, and then 1 plus 2 is 3. So you know that you've done your work right because you have 3 total electrons accounted for. All right, let's try one that goes into our P section. Let's try carbon. Okay, so how this works. Carbon is in our P section right here. We still have to account for our S sections that were filled up before carbon. Look at this. We have to account for our 1s section that was filled before we get to carbon. We have to account for our 2s section, and now with carbon we're on our 2p section. You see how that's a progression? Fill here, fill here, fill here, fill here. If we look back, we know our 2p section or our p section can hold 6. So we know this is full. 1s1, 1s2. That's full. 1s2. We know that's full. Then we move down here, 2s1, 2s2. Okay, we know our second s1 is full, because remember the s's right here can only hold up to 2, so as soon as you've got 2 there, they are full, so 2s2. Then we have entered our p section, and for our p section, we still look at our row, so it's still in period number 2, and now we're starting over with the columns in terms of counting them for our p section. Like this was column 1 for s, this was column 2 for s. This here, with boron and aluminum, this is column 1 of the P section, column 2 of the P section, column 3 of the P section. So we count. So we have 2s1, 2s2 filled. Now we're on to our 2p section. 2p. Boron would be 2p1. Boron would be 2p1. Carbon, therefore, is 2p2. So we put a 2 right there. And that is our electron configuration for carbon. Let's check our work. Carbon has a total of 6 electrons. Do we have a total of 6 up here? Yes. We have 2, 4, and 6, just like that.